Okay. Please welcome Guy Korland, the CTO of Innovations at Redis Labs.
So I only have 20 minutes, as I've been told. And this presentation I prepared to RedisConf, so it's a long one. It's a 40-something minutes. So I'm going to rush it a bit. But it's going to be like about 10 minutes. I'm going to talk about the philosophy and what we are trying to achieve in Redis Labs and the multi-model. And why are we building all these models and how we envision the future of Redis, or what you'll be able to do with Redis in the future, or most of it today. And then the last 10 minutes, I'm going to probably run, if I'll have the time for it, I'm going to show you a quick demo. I hope it's going to be funny enough, about what you can do with Redis, with the different models, and how you can turn Redis really into a multi-model database. So I'll skip all of that, but you probably noticed that as everything in computer science, everything is circular, like everything is coming back, right? The database started as a navigational graph-style database, and then relational generical database, and then today everything came back to be a specific database, NoSQL, going back into, and everything goes in circles. And when I'm talking about circles, you probably notice that today you have so many different databases, so different, like Iftach said, like so many different models, and the ones that are growing the fastest or the trendiest are the ones that are specific to specific tasks. So you have the relational, and obviously you have the document database, from which most of the NoSQL or non-NoSQL are providing, but then you have a more specific, like obviously like key value that Redis provides, and the graph database, which grows very fast lately with all the different products that are already there, and time series, and Iftach just introduced the time series that is part of now our portfolio of models. And you have a search. So you have so many different databases, so many specific databases for specific tasks. And as the database arena started with specific database for specific tasks, I think we are back to this situation where we have so many different databases, and generic database like relational database is not enough for many of the tasks, even though it's still dominating the market and it's still the most used database. Like most of the organization are still using relational database somewhere in the organization, and it's the default, obviously, database for most of the tasks. But there are so many other options today, so many other specific database, specific models for specific tasks, and you really see it growing. Like the same graph that Iftach presented, like it's really growing pretty fast, and the trends are all around these specific databases. And it comes from a reason, right? You want to get better results, you want to get lower latency, you want to get better application, you want to serve higher throughput. But when you still want to answer just these simple questions, like that many e-commerce or many recommendation platform will try to answer, it might start become complex. Like you want to answer this simple question: please find a restaurant my friends recommended within 3 miles radius. A very simple question that you might expect from any recommendation application. So how you would approach this query? So you're probably going to use some graph database because you want to find what your friend recommended, and you're going to use some, I don't know, maybe serverless platform like Lambda. And then you want to answer the second part, so you probably going to have some geo information or some database that can answer these questions. What are the restaurants that are in the 3 miles radius from me? And then you need to somehow merge this data. But that's not the hardest part. You need to make sure that they are correlated, right? That they are synchronized between them. So every time you introduce a new restaurant, you need to introduce to both databases. So you need to keep on synchronizing this database. And then your manager might come or your customer come and ask for another feature. Maybe I want to find how many visitors are visiting this restaurant because I just want to go to restaurants that are loaded, or maybe I don't have time, so I just want this restaurant that are unpacked. So I need to add some time series database that can measure the visitors and the load And again, I need to synchronize between these 3 different databases. I need to have this Lambda with, whenever a new restaurant is introduced, I need to synchronize the 3 databases somehow in some kind of transactional way. I need to keep maintaining these 3 databases. I need an IT for these 3 databases. I need my IT guys to know how to manage this, or my operations guy to know how to monitor these 3 completely different databases with completely different scalability and operation systems. And then if I'm extending it even better, and since I'm in New York, I'm probably going to look for a falafel place, so I'm going to need some search database, right? So I'm probably going to take some search database. You all know this logo, and I'm going to introduce it into the system, and I'm going to duplicate the data again for the 4th time. So I can get a free text search system, again, another system with a different scalability system that I need to synchronize between the 4 different databases, which means that I need to manage a lot of operation to answer a question just because the database has moved into this specific databases, specific model databases, from a good reason, because I wanted a very good performance. I want to reduce the latency. The relational database could not answer these kind of questions fast enough for me. But I got into this other problem now, that I need to somehow manage all these different databases in parallel. And that's not something that I invented. That's the recommended architecture that AWS recommend when you want to deploy this kind of an application. That's how they recommend. That's how they presented it in the last conference. You need this graph database, you need Redis for the Geo, you need search, Elasticsearch, and you need some Lambda to synchronize between them, and then a cache on top of a cache. And that sounds reasonable for them. And that might not sound so hard when you're working in the cloud, because it's all managed and you don't need to manage all of it like you would have done on-premise, right? But it's still a lot of things to manage, to understand how they work, how to synchronize between them, and somehow monitor. So Redis is everywhere. And we believe that if Redis is everywhere and Redis is fast and extendable because there is module API, we can extend it to different categories. We can allow Redis to be a multi-model, a real multi-model. And for that, we developed these different modules that support different model of databases. So I don't know if you know them all, and I think that's the most important slide on my deck. That's that you know these models and maybe look for them later. So you have a JSON API for Redis if you want to extend to be a JSON like a document-based. You have a graph API if you need a graph database. You have a time series API that we just released, and you have the search API, and obviously you have the key value that came from Redis. All of them together target the same idea. Simple as Redis, fast and low latency as Redis. But we wanted more than that. We didn't want you to just move all your load to Redis and get again into the same issue, like synchronizing between different API just in Redis. We think we can get you more than that. And in that, when I'm talking about more than that, I'm talking about synchronizing the data between the different modules, like allowing the different modules to interact between themselves and utilize Redis as the storage behind the scene. So now you can have a single storage, which is Redis. In most of the cases, it's just a key value hash or something like that. And then the different APIs expose the same data and allow you to get these specific API for your specific needs without the need to synchronize the data between different systems, without the need to know different systems, without the need to operate or monitor different systems. So let me show you like real-life example in my case, I think. You probably know this movie, Total Recall. I'm not talking about this one, by the way. This is a fake. I'm talking about the original one from the governor, right? So, so this movie is very realistic, as you know. It's all resides on Mars, and there's a cast there. And let's start building an application for this movie. So there's a cast, and the cast is starting with 3 different actors. Let's see how we store it in Redis. I think I'm going to store it as a simple hash. Okay, so let's start a Redis. Oh, sorry. Okay, let's start a Redis again. Oops, here you go, here's a Redis. And let's start by, I'm sorry that I skipped it all because I want to make sure that I can do it faster with you. So the first thing I'm gonna do is I'm gonna load something that you'll remember in the back of your hand, a model called Redis Gears, something that will help me kind of attach all the different parts. And the first thing I'm going to do, obviously, is going to load these three different actors, the cast. So the cast is these three actors. I'm just doing the age set. I'm loading three different actors. This is what I will call a vanilla Redis, right? So up to now, I didn't introduce anything new. But as before, with the formal application that I presented, I want to do more than that, right? I don't want just to store these three different the cast. I want to be able to do more than that. So I want to have some free text search, right? I want to be able to do some IMDb style search, and I want to search for this to see who is playing in this movie. For that, I'm going to introduce a new model. So all I have to do now is to load the Redis search module. That's all I have to do. So you can see here on Redis side that the model was loaded, and now I can just start searching. How do I do that? So the first thing I need to do, I need to teach Redis or teach Redis search how the schema looks like. So how the schema looks like. So how to like parse the data or how to present the data in the index. And then I need to tell Redis Gears, and that's a Python code which is written in Bash, so it's not that clear, but the idea here is that I'm telling Gears to monitor every hash that is stored in Redis, and take every hash that is already stored in Redis, and kind of tell Redis search, start index it for me. Don't copy the data, just start indexing it for me, so I can start searching on it. So it's taking the hashes that are already stored in Redis, and allows me to run something like that. Right, so I'm looking for, you see I'm looking for everyone who is starting with QU, and he's a marksman, right? And I'm getting these two guys. So I just introduced free text search. I can do every free text search I want now, like you would expect from any search database. And then, obviously, the cast might grow, and I might need to add more actors to the database. And as I said before, I register Gears to listen to every new hash. So now if I introduce a new hash, like these, you see I just added 3 new hash, I can immediately start searching on them. I'm still using Redis API. I didn't use any search specific API. My application, my data generator continue to work as it used to before I introduced Redis Search. But now, Redis Search is always keeping with the data. So I can just do like that, right? I can now search for someone who is starting with an MCC, and I'm getting this actor, Bob McLean. But let's make it more complicated than that. So I have relationship, right? I have actors, they have relationship. I discovered that they know each other during the movie, so I need to somehow represent this relationship and maybe be able to query against it. So I know that Douglas and Laurie are man and wife. So I just need to introduce a new model now. So the next model that I'm going to introduce now is Redis Graph, which allows me to model the data as a graph database and then query against it and maybe traverse the database. Again, the first step that I need to do is to load Redis Graph, the model itself. And then the next step I need to do is to introduce some data, because when I introduced the data originally, I didn't introduce any relationship. So what I just needed was that to say that add a new field to the age set of Marksman 101 and tell it that is in relation to 100, to Marksman 100. So they are married in a sense. Until now, I didn't do anything that is not Redis Graph specific. I just need another command, an edge set command. Now what I need to do is to do the same thing that I've done before with the Redis Search. I just need to deploy another. By the way, you don't need to copy it or try to understand what's going on here. You can see it online. It's on GitHub. I'll show it to you later. But I've done the same thing here as I've done before with the Redis search. I introduced 2 new Python scripts using Redis Grid. And the first one is just following the hashes to make sure that every time I introduce a new relationship, I update the graph. The second one is please index the ones that are already stored in Redis as a graph entities. So now I can do something like that. I can run a Cypher query, as I would have done with other graph databases, and ask, find me a relationship, and return these names. And as you can see, it returned both of them as in relation. So Laurie is in relation with Douglas. And I can introduce another maybe relationship. I can say that 105 and 100, I think that one is an employee of another or something like that. And as I told you before, I'm following the data all the time, so I can query it again. So now if I'm looking for someone in relationship, I can see that Harry is in relationship with Douglas, and Laurie is in relation with Douglas. So again, I didn't change the way I'm introducing data to Redis. I'm just making the modules following the data that is already stored in Redis. Oh, yeah. So relationship might be changed and might be broken. It happens from time to time. So I can delete the relationship. Obviously, I'm getting a notification. I'm updating the graph. So now if I'm looking for the relationship that are already stored in Redis, I'm not going to get it, right? He's still working for Harry, but the relationship didn't succeed. And last, oh, sorry. If you remember the movie, it ends in this horrible, in this horrible image when he didn't get enough oxygen, and so his biometric. So I needed an example for the time series, so I wanted to do some biometric information. So let's assume that probably his heart rate got higher and his breath, and so I now can introduce maybe a time series database, and I can follow the data and I can update the data in the same way as I updated before using the Redis API, and make this module follow Redis and update the time series accordingly. So how we're going to do it? Again, I think you already got the idea. I'm going to introduce a new module, the time series, which again is going to follow the data that is already stored in data, and all the updates that are stored happen in Redis, and then generate a time series data that you can then query using the time series API. So again, I'm going to introduce some gears script that will follow every change that is happening on Redis. In this case, I've only done the script that is following changes. And I'm going to start introducing data. So what I'm doing, if you look at the script that I'm showing here, I'm just calling HSET again and again with different values. You see? I'm just updating his heartbeat again and again. And every time I update in his heartbeat, gears catch this update and generate a new entry into the time series. So I'm using an update, HSET update, a simple update as you might expect when you are working with Redis. By the way, this heartbeat is just getting down because you got oxygen probably. And I just got data in the time series. So if I'll call the time series API, you see here I'm calling TS range on 100. I want to take everything, and I want to aggregate average every 5 seconds in this case. So I just retrieve this average heartbeat per 5 seconds on a data that I updated on Redis API. So I didn't need to change anything on my ingest platform, but I introduced new APIs and new functionality to Redis while I'm not touching the data, I'm not restarting the platform. I don't need to install any new platform. I don't need to sync anything. The platform is keep following the same data that is stored in Redis. Sorry. Oh. OK. So that's the end of it, of the demo. So just let me summarize what I just showed you. So this is the cast of this little movie that I just showed you. So obviously you have Redis, and you have Redis gear, so is it like connecting all the different dots. And then you have Redis Search, which allows you to do free text search, and Redis Graph, which allows you to do graph traversal. And we ended up with Redis time series. And all of them, again, following the same data that is stored in Redis, just allowing you to do more and more different APIs according to your requirement, and making sure that your query is optimized. It's not like if you're using a relational database and you need to compromise on the performance. Here you are getting the optimized performance for your different needs according to your application. On the follow-on movie, there might be other casts, but these are other models that we have that will follow the same ideas. The example is stored here, so if you want to look at it, it's there. There you can find in Redis Gears, you can find other examples for Redis Gears, how we are doing like image classification on the fly, or stream processing, or transaction modeling, or stuff like that. And you can play with Gears. Gears is not GA yet, but it's getting there. That's it. Thank you.